in and be seated. Good afternoon, and welcome to this amazing occasion that we have planned for you today. I'm Richard McCarty. I'm Dean of the College of Arts and Science, and this is one of the great moments in the history of any College of Arts and Science. And I'm delighted that we have so many people here today. Visitors, faculty, staff, students, and friends of the Bess family. This special occasion has been made possible, this Chancellor's Chair in History, by an anonymous donor. And I can only tell you the level of generosity and the level of anonymity involved in this really are amazing. To endow a chair at a university like Vanderbilt is an investment in the future of a place of higher learning, and also an investment in the present, a celebration of a great faculty member with an amazing track record built on excellence in the classroom and excellence in research. Before I introduce our featured speaker and honoree today, it's my pleasure to introduce our interim chancellor, Nick Zeppos. I could say a lot of stuff about Nick, but I think I'll just tell you that without Nick, there would be no Chancellor's Chair in History. He's been remarkably supportive of Michael and our attempt to keep him here at Vanderbilt until retirement. That's the goal. And I think with Nick's effort, the probability of keeping Michael here for the rest of his career increased almost to a probability of 1.0. So Nick, without further ado.
Welcome everybody to this wonderful occasion, and this is, as we like to say, the time of the year where the campus really shows its best. And when that comes to mind, it's usually this idea of a beautiful long fall in this wonderful city of Nashville at this great university. But what I'm thinking about is really what Vanderbilt does best, which is teach, discover, do research, and make a tremendous difference in the world. And so we're into about the fifth or sixth week of the semester, and indeed, this is an exciting time of the year. Now, I'm in actually the school where I began my career, although this room was not here. We had something in a kind of lime green color with interesting swivel chairs on them. It's always been a privilege to be at Vanderbilt, and I certainly feel privileged serving as the interim chancellor and being able to participate in this very important occasion of inaugurating a chair. I'm a law professor by training, although I was a history major as an undergraduate, so I never play favorites with departments, but I do have a soft spot in my heart for what I think is one of the most important human disciplines at our university. Let me talk a little about the College of Arts and Science and this great university. The College of Arts and Science is the centerpiece of any great college or university. It is the most important school in what is teaching, research, and discovery at a great university. It's the core. Universities, including Vanderbilt, talk about being more interdisciplinary, more trans-institutional. How can we connect those things together? Well, the College of Arts and Science itself covers the breadth and range of discovery, teaching, and human discourse. Biological sciences, chemistry, physics, religious studies, history, English. So it is impossible to think of being a great university without a great College of Arts and Science, and it is impossible, frankly, to think of doing important interdisciplinary or trans-institutional research without a College of Arts and Science. And I think we can see in Michael's work the kind of connections he draws across disciplines and across areas of inquiry. Now, the chair is indeed the ultimate honor that one can receive at a university as a faculty member. And for all the titles that appear at the end of my email addresses, you will not see an endowed chair because it is truly earned in an amazing way. It requires absolutely outstanding commitment to teaching. We are an educational institution, and that commitment to teaching, particularly in the undergraduate program, is pivotal in the decision to award a chair. It also requires a visibility and recognition, not simply by your colleagues on the faculty of your research and service and teaching, but by peers in the field who are asked to measure you not against just Vanderbilt, but the whole constellation of historians in your field. And Michael indeed spans many fields. So it is really kind of the ultimate honor that we can give. The donor here, as Richard mentioned, is anonymous. And if I told you, I'd have to kill you, as they say. So I cannot mention the donor. But it was an interesting process by which this chair came about. The donor insisted on anonymity, but a number of motivations were at play in this very generous gift. First was the centrality of history and the importance of history to a university's mission, but also the human condition. That if history doesn't repeat itself, as my good friend Tom Schwartz says, Mark Twain quoted, history doesn't repeat itself, but it does rhyme. And so what are the lessons that the historian can give for the time in which we live, and how does the historian write a history of those periods through which we lived and think we remember and understood? The donor also wanted to invest in our outstanding Department of History. The donor not only believed in history as a discipline, but the donor believed that Vanderbilt should have one of the greatest departments in the world. And so the donor was deeply motivated by what is, by any measure, a truly outstanding department. I can see some of our emeriti faculty here, Paul, who've contributed to that department, and many newcomers as well. The final thing, of course, the motivation was Michael. We had long conversations about Professor Bess and discussions about his commitment to the students, his breakthrough work, his willingness to take risk in teaching, but also in his research, and the pivotal role that Michael plays not simply as a scholar and teacher, but importantly as a citizen of our university community. I won't say that fundraising is easy, but this was one of the easiest gifts to come Vanderbilt's way, because it's a description of Michael as a person and as a scholar, along with these other goals the donor had, made this a very, very quick sale, as we'll say. Now, what about the first chair? What about the inaugural chair? You know, what are the first footprints in the sand, or what's the first kind of wearing on the chair as the person sits in it? Well, we're in the law school, and we can say the first chair sets a precedent. It says, what is this chair about? And one of the most interesting things to look at is who holds a chair and who's held it before. There's nothing more important than to get off to a fantastic start and set a very good precedent. And I think, as we all agree, we've done that with Michael. He is an absolute first-rate scholar, a wonderful teacher, and I think those who will come, and as I always say, these gifts are for eternity, those who will look back and see that Professor Michael Bess was the first holder of this chair will indeed be inspired and have to meet very, very high standards. Now, I've known Michael pretty much 18 years, Michael, you've been here. One of the first pleasures I had of interacting with Michael was he was nominated for a teaching prize. And I was on the committee that was awarding those prizes, and we went to see the faculty who were nominated go teach. And so Michael was actually teaching kind of a modern European history class. And it wasn't on an area that's usually popular or kind of well-worn. It was on actually the history of Spain and Portugal and Europe, Western Europe after the war, with a particular focus on countries that are often ignored. Being the history major I was, I eagerly went to that class, And it was filled with bright, engaging, interesting students in a dialogue with Michael. He even wore a tweed jacket, so it just confirmed my image of the great college professor. I left that class and I said, well, I went to some other classes too, and we have very fine teachers on this campus. And I said, well, Michael's the sure winner. And I told the committee, I said, the students admired him, they were engaged, they were prepared. And I said, if I had to sign up for a class in my free time, I would take Michael Bess. I also want to mention that we get in these discussions sometimes with the history department. Is history a humanities or a social science? And it's kind of an interesting discussion to have. The thing I'd like to emphasize, I always say we're all humanists because we're all consciously focused on inquiry into human events and the human experience. But Michael really does represent the historian's craft in the best way. He brings the historian's passion for exploration but interpretation together in interesting areas and draws connections that only the well-trained and really brilliant historian can make. Now, let me just close by saying there's something also quite remarkable about Michael that I want to emphasize to everybody here, alumni, students, faculty, and it is the close intersection between teaching and research that Michael embodies. And when you're in a university, you're often posed questions like, well, why do we do research? Or, they should be more in the classroom. And what's important to realize is that at a research university, they are one and the same. And that when a Michael Bess walks into a classroom and teaches, it is an outstanding class because of his important path-breaking work. Nowhere better exemplified than Michael's book on World War II, where students who took his class read his chapters in draft and criticized Michael's work and questioned Michael's work and were part of the scholarly process with Michael. And what better partnership between faculty and student than the interaction over a piece of scholarly work as they meet in the classroom. So we're very proud to have Michael here as our first Chancellor's professor. I'll say this, speaking to the donor, who I can say is not here. So if someone is kind of wondering and looking around and saying, is Mr. Anonymous here? Let me just speak to the donor, since this is being webcast. We want to thank him or her for this very generous gift and honoring the university with this enduring commitment, not just to Michael, but to Vanderbilt and our outstanding Department of History. The donor said, I want to be a leader, and I want to recognize leadership. And he was convinced, she was convinced, that Michael was a leader in his field, that he was a leader for his students, and that Vanderbilt should be a leader in history. So I want to thank our anonymous donor for believing in Michael and believing in Vanderbilt. And I want to thank all of you for coming, standing room only, to this really wonderful occasion. And let me now turn this back to Dean McCarty. Thank you very much.
I now have the pleasure of introducing Michael Bess. Nick has done a great job of providing a prelude. And I don't quite know where to begin. So I'm going to begin with a personal effort. The first fall semester I came to Vanderbilt, I was invited to the history department party. And it happened to be at the Bess's house. And it was just a great way for me to experience the incredible warmth of this family to open their home to their department, as well as a number of other close colleagues. And many of you in this room today were at that party. And it was the first time I met many of you. But I've always remembered that as a time when I first got to know this extraordinary family. And I'll never forget the experience. I'm also struck by how often I use Michael as an example. And Michael sets a high standard for all of us. But I think every alum that I talk to wants to think of Vanderbilt faculty in the way I think of Michael Bess. And that is someone who is incredibly energized by the classroom experience, but also a fiercely dedicated scholar. And from the outside looking in, there's never an obvious tension between these two things. So let me move to the formal part of telling you a bit about Michael, if you don't know these details, because I think they'll give you a great sense of the person delivering the lecture today. Michael received his undergraduate degree at Reed College and was elected to Phi Beta Kappa. He then continued his graduate studies at UC Berkeley, where he received the PhD in 1989. And then he made, I think, the very good decision to come to Vanderbilt and started in the Department of History as an assistant professor focused in 20th century European history. The time since his arrival has been marked by many, many superlatives. His first book, and I've got to flip to the page, Realism, Utopia, and the Mushroom Cloud, was published by the University of Chicago Press in 1993 and played to wonderfully supportive reviews. His second book actually, I think, was sort of playing in even a higher level. When he wrote The Light Green Society, Ecology and Technological Modernity in France, 1960 to 2000, again, working with the University of Chicago Press, the reviews came in, again, overwhelmingly positive, and he was recognized with the George Perkins Marsh Prize for Best Book in Environmental History of 2003. Michael's third book has already been mentioned by Nick, and it's an extraordinary book because it grew out of teaching. And it continued this interesting pattern. We needed the third book to see if the pattern was consistent with expectations. Michael has a very active mind, and he doesn't stay on one thing over and over again. He's constantly looking for new avenues. So his third book, Choices Under Fire, Moral Dimensions of World War II, was actually a book I sent out to many of our most generous alumni to give them an example of what Vanderbilt faculty are working on. And I was amazed at the response I got to this book. It really captures some of the critical decisions made in World War II, but presented in a way that it speaks to us today with some of the great challenges that our nation faces in finding its proper place in the world. So we've got great teacher. How many students have had a course with Professor Bess? Oh yeah. And how many thought it was an amazing experience? Yeah, about 100% concordance. And that's what we hear constantly about this extraordinary person. So if we put all the teaching awards in front of you, we'd have to have the wagon to get them in here. We've run out of awards. Michael has done just about he's run the table, and for good reason. But he's done a lot of other things to make this a great place to be for faculty, students, and staff. He's currently our faculty council chair. I think he may have missed the meeting when the election occurred. That often happens to the faculty council chair. But he's someone who has really led our council already this year with great distinction, and we have a long academic year to go, and it's wonderful to be able to count on Michael. Now, many of you who know Michael well know also his love for Italian and French. And we took advantage of the French side of his brain and He was our professor in residence in Aix-en-Provence and had, I think, kind of a wonderful year, yeah? A wonderful year and a great year for our students, and he added a very unique dimension to that study abroad experience. It's just overwhelming to think how fortunate we are to have Michael here and to have this generosity of recognition of his great talents. So I'm not going to take any more time other than to tell you you're in for a treat. And Michael's talk today is Icarus 2.0, Genetics, Computers, and the Quest to Build a Better Human. I'm delighted to introduce Michael Bess.
Thank you so much, Chancellor Zeppos, Dean McCarty, for those embarrassingly generous words of introduction. Thank you so much. And I would also like to join both of you in thanking the anonymous donor whose generous gift to Vanderbilt made possible the Chancellor's chair in history. Just because I don't know the donor family's name, this does not mean that I can't be sending out into the ether intense vibes of gratitude, which is exactly what I've been doing. And I'm deeply honored to be the first holder of this chair. Anyone who has perused the acknowledgments section of my last book, the one that Richard was referring to about World War II, anyone who's looked over the acknowledgments section in that book will know that if I start actually thanking all the people who have made this day possible for me, we'll be here this evening for a very long time. Indeed, one of my more sardonically inclined relatives went so far as to observe that if everyone in my acknowledgments list actually went ahead and bought the book, it would be sort of ipso facto a bestseller. So I will spare the detailed thanks and merely state my fervent gratitude to all of you, my family, my friends, and my students and colleagues. My talk today is about major technological watersheds in human history, the great tectonic shifts that mark the transition from one epoch to another. I'm going to argue that we are entering one of these epochal transitions today in our contemporary world, and that our society is not at all prepared for the swift and radical changes that we are about to experience. Many of the most important transformations in human history have been associated with new applications of technology to the basics of everyday existence. For example, the shift from stone tools to metal implements that's one good example. Another would be the transition from nomadic hunter-gathering to settled agriculture. A third example comes in the 18th century, the substitution of steam power for human and animal sources of energy. Well, today in 2007, we are in the early stages of a transformation that will prove equally as momentous as those other great watersheds in human history. Once again, as in the past, the key to the change lies in technology. But this time around, there is one important difference. This time, the innovations are not being applied to refashioning our tools, our methods of food production, our means of manufacturing. This time around, it's our bodies themselves that are the objects of refashioning. We are applying our technological ingenuity to the challenge of redesigning ourselves, redesigning our own physical and mental capabilities. Now, in the past, these major historical disjunctions have all come about relatively gradually, sort of spread out over centuries. So people and social systems had time to adapt. Over time, people were able to develop new values, new norms and habits to accommodate the transformed material conditions. But this is not the case with the current shift. This time around, the radical changes will come upon us with relative suddenness. In a matter of decades, a half century at most. And it's not clear how successfully our social institutions will be able to adapt. And that's the subject of my talk today. What I'd like to do now is to tell you two brief stories. They're both, in a sense, Promethean stories, tales of the human aspiration to rise above earthly limits. I think they do a good job of illustrating the nature of the revolution through which we're all living. So the first story. In 1997, a 53-year-old man named Johnny Ray had a massive stroke while he was talking on the telephone. This otherwise healthy man, who worked as a contractor in Douglasville, Georgia, collapsed on the floor and lost consciousness. When he woke up several weeks later, he found himself in a condition so awful that most of us would have a hard time imagining it. It's called locked-in syndrome. You are still you, but you have lost all motor control over your body. You can hear what people say around you. You can understand it. You have thoughts and feelings, but you cannot respond. You just lie there, inert. So even if you wanted to scream in frustration or despair, you can't. You're frozen. You're locked in. The only way Johnny Ray could communicate was by blinking his eyelids. One blink for no, two blinks for yes. In March 1998, two neurologists at Emory University and Georgia Tech inserted a wireless implant into the motor cortex of Ray's brain. The implant transmitted electrical impulses from Ray's neurons to a nearby computer. The computer interpreted the patterns of brain activity and translated them into cursor movements on a video screen. After several weeks of training, Ray was able to think up and thereby will the computer cursor to move up on the screen. After several more months, he was able to manipulate the cursor with sufficient dexterity to type out messages to those around him. So he was literally controlling this machine by thought alone. And by that point, the brain-computer interface had become so natural to him that using it seemed almost effortless. When the doctors asked him what it felt like to move the cursor, he spelled out N-O-T-H-I-N-G. Felt like nothing. Johnny Ray had escaped from his terrible isolation and moved back into the rich world of language. So now here's a second story. This one is about a 4-year-old girl named Ashanti De Silva. She was born in 1985 with the genetic disorder that has come to be known as bubble boy disease. Her body lacked the gene required for making a protein called adenosine deaminase, or ADA. Without ADA, her immune system was drastically impaired. Just about any viruses or bacteria she encountered could easily attack her body and threaten her life. So she lived in total isolation at home, kept alive by injections of synthetic ADA. Her parents knew, moreover, that the life-saving effect of these injections of synthetic ADA the life-saving effect was inevitably going to diminish over the coming years, and that their daughter would eventually die of her disease. The only other alternative, a bone marrow transplant, was impossible because no compatible donor could be found. So, out of desperation, Ashanti's parents turned to what was at that time cutting-edge experimental medicine. In 1990, at the NIH Clinical Center in Maryland, a team of doctors extracted blood cells from Ashanti's veins. And then they used a hollowed-out virus vector to insert working copies of the ADA gene into those blood cells. They were, in effect, repairing the deficient gene that had caused her disease. When those modified blood cells were injected back into Ashanti's body, the results were dramatic. Within 6 months, her immune system became sufficiently active to allow her to go safely out of the house. Within 2 years, she was enrolled in school and began, for the first time, to experience a normal childhood. Ashanti da Silva is alive and healthy today, though she still requires periodic renewal of the gene therapy to boost her body's immune response. Her story constitutes the first case of successful gene therapy on humans. So these two stories about Johnny Ray and Ashanti da Silva, I've told them because they have some striking features in common. For one thing, it's remarkable in both these cases how far the science and technology have already come since these two pioneering feats were first carried out. Johnny Ray's brain implant, installed in 1998, possessed only a single electrode for linking up with his nervous system. So one electrode. In the 9 years since then, an owl monkey in a lab at Duke University has been equipped with a brain implant containing 700 electrodes and a high bandwidth interface. And so this far more sophisticated device has allowed the animal to progress even more rapidly than Ray. The monkey stares at a video screen, its arms dangling motionless at its side. Using thought alone, the monkey deftly controls the movements of a robot arm in another room. Up, down, sideways, back, the mechanical arm responds to the animal's mental commands. Without moving its own body, except its eyes, the monkey plays video games using its new arm and appears to have seamlessly incorporated this remote-controlled appendage as if it were part of its own physical being. Human trials on this line of technology are already in the works. More than a dozen universities and private companies are currently in a race to push this field still further. The progress in genetic technologies has been even more dramatic in the 16 years since Ashanti da Silva got her injection of genetically modified blood cells. In 1997, Dolly the sheep became the first successful clone of a mammal. In 2003, the Human Genome Project produced the first complete map of human genetic material. In the year 2004, there were 987 gene therapy trials underway around the world. 987. So that's one feature that these two stories have in common, the dizzying rate of acceleration in the development of biotechnology. A second common feature is less obvious but equally important. The same techniques that render healing possible inevitably also render enhancement possible. If I can place a brain implant in Johnny Ray to let him out of his locked-in world, I can also use a very similar technology down the road to let healthy people manipulate robotic arms by thought alone. One development leads to the other. If I can insert new genetic instructions into Ashanti's blood cells, making them produce ADA, then I can also use a very similar procedure down the road to make other human cells produce other proteins of my own choosing. Again, one technique leads directly to the other. The technologies for repairing a malfunctioning human body are inseparable from the technologies that allow us to push human capabilities to ever higher levels. Where we can heal, we can also tweak, boost, magnify. Where we can repair, we can also modify, reconfigure, redesign. One fascinating feature of this phenomenon is how much it all sounds like science fiction. The bionic woman, which has just debuted again after a 30-year hiatus on TV. Bionic woman, the clone armies, the intelligent robot, the genetic mutant who becomes a superhero. These are all characters and images that have come into common currency in contemporary culture. And yet, this link with science fiction is potentially misleading. Precisely because we associate human enhancement with the often bizarre, futuristic worlds depicted in novels and movies, we tend to dismiss the evidence that is steadily accumulating all around us. The technologies of human enhancement are gradually, incrementally, becoming a reality in today's society, but we don't connect the dots. Each new breakthrough in genetics, robotics, prosthetics, neuroscience, nanotechnology, psychopharmacology, brain-machine interfaces, and similar fields, each new breakthrough is seen as an isolated, futuristic event taking place in an otherwise unaltered landscape. So we read with interest about it, and then return to business as usual, assuming that the world has not fundamentally changed. What we miss when we do this is the cumulative importance of all these developments taken together. Let me just briefly sketch what's happening today in the three major areas of enhancement science. I'll start with the domain of pharmaceuticals. People are using chemicals in increasingly sophisticated and powerful ways to reshape their bodies and their minds. I need not belabor the importance of chemicals such as steroids, which enhance physical traits like speed, strength, and endurance. Now, these types of enhancements have shaken the world of competitive athletics to its foundations, and the end seems to be nowhere in sight. But the realms of human cognition, learning, and emotion are being shaken up in equally profound ways. Behavioral traits such as distractedness, short attention span, which used to be treated as problems of character and willpower, are now being medicalized and redefined as treatable illnesses for which powerful pharmaceuticals, like for example Ritalin, can be prescribed. Conditions such as depression, which used to be approached through endless hours on the psychiatric couch, are increasingly being handled through the administration of an ever-growing array of neurotransmitters, hormones, and other mood-altering chemicals. In the process, our society's sense of what constitutes normal ability or basic mental well-being, our sense is being radically, of these things is being radically destabilized. As Carl Elliott describes it in his book, Better Than Well, we are engaged today in a sort of chemical arms race, seeking to push our physical and mental abilities to ever higher levels. For example, when college students discovered that certain attention deficit drugs, like Ritalin, would also boost cognition and memory in a purportedly normal individual, you can easily guess what happened next. A black market rapidly developed for perfectly healthy students seeking that extra edge in their schoolwork. Most of those who took the drug reported that it helped them think more clearly, concentrate better, and remember information far more accurately than before. And for many students, given the competitive nature of our educational system and of our broader society, the temptation to enhance proved irresistible. So, pharmaceuticals. A second important area of human enhancement lies in the field of neuroscience and its intersection with the technologies of prosthetics, robotics, informatics, and artificial intelligence. As the story of Johnny Ray makes clear, the boundaries between human body and information processing machine are beginning to blur. Johnny Ray became a kind of human-machine hybrid, in the sense that key aspects of his individuality, his ability to communicate in language with other people, came to be linked to the functioning of machine components that he had incorporated into his being. Now, for the present, such deliberate blurring is taking place only in experiments with animals or in extreme cases like Johnny's, where a person has become severely disabled. But that is not where much of the research is pointing. In the coming decades, such human-machine hybrid functions will proliferate. We will have the ability to link directly into the human sensorium, into the human nervous system, with an increasingly broad array of powerful devices. Some of the blind will see again. Some of the deaf will hear again. Some of the paralyzed will walk again. Now, this does sound like science fiction. But let me give you an example of how far we've already come today. In 2002, a brain researcher named William Dobell made headlines by partially restoring sight to a fully blind patient. Dobell implanted electrodes in the man's visual cortex and linked them through a portable computer to a tiny video camera mounted on the man's glasses. The result was grainy, blurred vision, but vision nonetheless. Dr. Dobell's blind patients could see well enough to actually drive a car around a parking lot, slowly, and to carry out simple everyday tasks like cutting wood, for example. And here, as before, the technologies of healing will be inseparable from the technologies of enhancing. If I can put a functional artificial eye into a blind man, restoring his sight, then it's a short step, technologically speaking, to include additional features in the implanted device, such as a telescopic lens or an infrared sensor. So now we have a formerly blind person who can not only see normally, but who can also zoom in clearly on very distant objects and see extremely well at night. He can see, in Carl Elliott's words, better than well. Now, if this technology becomes safe and affordable, it would be remarkable if some people with normal vision would not start hankering to have their own optical sensorium tweaked with a similar technological enhancement. Now, needless to say, these kinds of developments have elicited great interest from the military. Significant funding for research in virtually all of these bioinformatic areas is coming from a Defense Department agency known as DARPA, Defense Advanced Research Projects Agency. What DARPA envisions is a battlefield of the not-so-distant future in which humans and machines are deeply interwoven at all levels. Imagine a soldier who can sprint at top speed for 5 miles with a heavy backpack, yet not get tired because his blood has been altered to carry oxygen at a much higher level of efficiency. Imagine a soldier who can stay fully alert for 72 hours without needing any sleep because his nervous system has been modified accordingly. Imagine a pilot who controls his aircraft directly through a brain-machine interface by means of a wireless implant in his head, communicating seamlessly with the plane's computer. Now imagine the same pilot commanding an unmanned drone by remote control, using the exact same technology, but transmitting real-time instructions via satellite to an aircraft flying in another part of the world. Even if you are not imagining such things, DARPA is. And it's supplying considerable amounts of money to advance both the basic science and the applied technology for such capabilities. Not all the research I've been describing will bear fruit, of course. There will be many setbacks as our society goes down this road. But this should not obscure the broader point. We are gaining ever more sophisticated understanding of how the human brain works, how the nervous system and sensory organs function. We are building ever more powerful robotic and informatic devices. And we are getting better and better at linking these two realms, human and machine, and teaching them to work as one. Over the next few decades, these functional hybrids will become more and more a part of our lives. Now, the third major area of human enhancement is, of course, genetics. It is potentially the most powerful form of enhancement because it can modify not just individual persons in the here and now, but entire lineages down through the generations. Most geneticists today believe that both nature and nurture, genes and environment, are critically important in making us who we are. Researchers have discovered that some horrible diseases, like cystic fibrosis, for example, are caused by malfunctions in a mere 1 or 2 genes. Fixing the gene heals the disease. Other intangible human traits, such as intelligence or shyness, are probably linked to complex systems of genes rather than to isolated genes. So if we adopt a musical metaphor, we can say that such traits depend not on single notes, but on entire symphonic harmonies of notes playing together. And of course, the upbringing, the life experience of each of us plays an equally crucial role in determining what kind of person we become. Nevertheless, scientists have also discovered that by altering individual components in certain systems of genes, we can directly affect complex and intangible traits in predictable ways. Let's take intelligence and learning as an example, since we're a university. In 1999, a biologist at Princeton, Zhou Chen, modified a single gene in laboratory mice, a gene that controls the production of a chemical known as NGF, or nerve growth factor. Chen tweaked the gene so that it boosted the production of NGF. To his astonishment, the NGF-enhanced mice performed up to 5 times better than normal mice in tests of memory, learning, and intelligence. Other biologists, such as Eric Kandel and Tim Tully, have tinkered with a different gene, responsible for the production of a chemical that strengthens brain synapses. Through genetic manipulation, they have significantly boosted the learning abilities of mice, fruit flies, and sea slugs. You didn't know that sea slugs could learn, but apparently they can. Now, let me be clear. This does not mean that genetic enhancement of human intelligence is just around the corner. But it does suggest something that should get our full attention. Genetic enhancement of basic human traits is no longer a topic of fantasy, of science fiction. The pieces of the scientific and technological puzzle are coming together in real developments happening today. Neuroscience and psychology are telling us more and more about the electrochemical basis of how brains function and how brains produce specific states of mind. Genetics is telling us more and more about how particular genes regulate the production of certain brain chemicals. Our technological ability to modify individual genes is growing rapidly. When you put these pieces together, you have a recipe for powerful genetic interventions to redesign human bodies and minds. The time frame, depending on which expert you happen to be listening to, is probably a matter of 2 to 5 decades. At some point out there, around that time, within the lifetime of today's college seniors, our society is going to face some tough choices about whether to use, how to use these extraordinary genetic powers. So, I've described 3 main areas of human enhancement: pharmaceutical, prosthetic informatic, and genetic. Let us suppose, for the sake of argument, that a majority of U.S. citizens were to decide today that human enhancement is a bad road. Our society should refuse to go down it. Could we stop these technologies from being developed? What would such a policy of relinquishment require? Well, the answer turns out to be sobering. Bringing the enterprise of human enhancement to a halt would require a draconian system of surveillance and regulation governing vast areas of science, technology, and medicine. Precisely because the technologies of healing and the technologies of enhancement are intrinsically connected with each other, a ban on enhancement would prove ineffectual unless it severely curtailed research in such areas as computers and informatics, genetics, robotics, neuroscience, nanotechnology, cognitive psychology, pharmaceuticals, and many, many fields of contemporary medicine. Moreover, a ban would require this highly restrictive system to be imposed equally rigorously in all the world's nations at the same time. Or, if that didn't happen, you would find the research and innovation simply migrating overseas to the least regulated regions of the planet. I don't know if you agree with me, but I believe that the chances of such a coordinated global relinquishment happening are very small indeed. Nevertheless, to admit that we cannot stop this process altogether does not mean that we're powerless to exert any control at all over it. So we may not be able to prevent the river from flowing, but we can, perhaps, channel it along a course we prefer. I see 4 main issues that these developments will compel us to confront. First, there's what I call the slippery slope factor. Human enhancement is going to be very hard to resist once you and I personally are offered it. It not only taps into our instinct for self-preservation, but it also draws on some of our most laudable impulses, our concern for those we love. Most parents go to extreme lengths to give their children the greatest possible chances of leading healthy, educated, and fulfilled lives. If biotechnology offers parents a product or a procedure that safely boosts those chances, how many will be able to resist? And how much greater the pressure will be on those parents when they know that their children will be surrounded by large numbers of other children whose capabilities will have been augmented in a variety of ways. Biotechnological modifications are likely to come in small incremental packages, each one offering a slight improvement in some aspect of our bodies or minds. As the science and technology advance each year, we will be offered a wide array of new products and interventions, biological, electromechanical, along a steadily increasing gradient of sophistication and potency. But at any given moment, in any given year, the various modifications we will be offered will not seem like such a big deal. On the contrary, they will, for the most part, seem like sensible and desirable extensions of abilities we already possess. The net result will be a social context in which the very meaning of the word normal is constantly shifting. What was normal last year becomes slightly subpar this year. What was normal 10 years ago is completely obsolete today. In this sense, what I'm describing is a lot like the world of computers. The fanciest, most powerful laptop computer from 10 years ago is basically a museum piece today. So, this is my first point. Once enhancement technologies become widespread, people will have to accept a continual, unending process of upgrades and boosts, simply to keep up with the ever-shifting baseline of normal human performance. This will not be something we can easily opt out of. It's inherent in the very nature of technological innovation. In this case, applied to our bodies and minds. My second point has to do with what this future is going to look like. I suspect it's going to be a lot weirder, a lot more unsettling than most of us are ready for. And popular science fiction has not been much help in this regard. From Star Trek to Star Wars, we certainly see a lot of strange critters running around. Intelligent robots, not so intelligent robots, bizarre species from galaxies far, far away. But all these strange critters exist alongside a bunch of perfectly ordinary-looking human beings. For the most part, the only humans who are profoundly modified are the evil ones. Think of Darth Vader in Star Wars or the Borg in Star Trek. I think this is a telling point. It indicates that we are psychologically unprepared for what is actually far more likely to happen. Over the coming century, some of us, perhaps many of us, will be increasingly merging with our machines, while at the same time modifying our own biology in ever deeper ways. By the year 2050, our society is likely to be populated by a wide variety of truly hybrid beings, part genetically modified human, part machine. Now, to be sure, some individuals, some entire family lines will no doubt have followed a conservative path, rejecting major modifications. But we can safely assume that many other individuals and families will have opted to push their enhancement possibilities to the max. No one can foresee today what those more aggressively modified people will look like or act like. But I suspect that from today's standpoint, they would be deeply unsettling to behold, both when they're at rest and when they do the things they do. Many of their behaviors will lie well beyond the range of current human capabilities. And so we should not underestimate the sheer strangeness of the future that awaits us just a few decades down the road. Which brings me to my third point. The social disruptive potential of the technologies I've been describing is hard to overstate. They hold out the possibility of liberating humans from many of their millennial constraints and afflictions. But they also hold out the possibility of dividing humankind more radically than at any time in recorded history. It's not at all clear whether a population of highly enhanced humans can coexist peacefully alongside a population of unmodified humans. There will be plenty of opportunities for prejudice, resentment, and dehumanizing stereotypes going both ways. From one side, we may hear insults like monster, freak, abomination. From the other side, the insults may run more along the lines of weakling, moron, pathetic relic. But that's not all. Within the population of the enhanced, we are also likely to see ever-growing levels of heterogeneity, ever-increasing degrees of physical and mental divergence, the likes of which human society has never before experienced. As I drive around town, there's a bumper sticker I see from time to time that says, "Embrace diversity." The diversity of the year 2050 is likely to challenge our capabilities for embracing, our tolerance and respect for others to an unprecedented extent. If human enhancement becomes widespread, then the people of that era will not only look far more different from each other than people today look, they will also possess a much wider variety of physical and mental powers. Diversity in such a context will be based on varying biologies, dissimilar machine components, sharply contrasting abilities. And so the question is, will we have a culture that can absorb that level of riotous heterogeneity among its members? And this brings me to my fourth and final point. None of us has a crystal ball, of course. Can't know with any precision what shape the civilization of enhancement will take over the coming decades. But the broad outlines of what is coming are already clear enough to see. Enhancement of human bodies and minds will become a defining feature of our society, whether we as individuals approve of it or not. And even if this development ends up taking twice as long as anticipated to become a reality, say it takes 60 or 80 years instead of 40, we are still speaking here of one of the great disjunctions in human history. A few decades more or less do not alter the radically destabilizing nature of the changes coming down the pike. Now, to some of you, this prediction may smack of technological determinism. Ultimately, you might say, it is humans who make technology, and therefore, it's up to us humans to choose whether or not to go down this road. Now, this is undoubtedly true. But my argument has been that the very nature of these technologies will make many, many people want to have them. And the collective impact of those desires, expressed as social and economic forces, will exert tremendous pressure to bring these technologies into being. It will be up to us citizens to decide just how and at what pace and in what configurations these enhancements enter our lives. That is most certainly not predetermined. Our responsibility as citizens, therefore, requires that we start preparing ourselves today as best we can for the new civilization that's headed our way. This will demand a great deal from us. It will require that we educate ourselves about the underlying science and monitor closely the ongoing developments in all the fields I've described. We will need to address basic issues of safety, devising effective ways to regulate the new enhancement technologies. Equally important will be the question of fairness, ensuring that opportunities for enhancement do not become the exclusive prerogative of a select few. Ensuring, in other words, basic equality of access to these technologies. If we fail in this, and some social groups gain preferential access to the most potent enhancements, we will witness a further widening of that cruel gap that separates people into haves and have-nots. But this time around, that gap will not merely be reflected outwardly in material possessions, social status, and power. It will be written in biology itself. Another challenge will center on the commodification of humans. Enhancement technologies pose a serious risk to human dignity, precisely because they tempt us to think of people as entities that can be improved. As soon as you take this step, you are, whether intentionally or not, breaking down human personhood into a series of quantifiable traits to be boosted or tweaked. Physical traits like coordination or stamina, mental traits like intelligence or sociability. The danger in doing this lies in reducing individuals to the status of products, artifacts, to be modified and reshaped according to our own preferences, like any commodity. And in this act, inevitably, we risk losing touch with the quality of intrinsic value that all humans share equally, no matter what their traits may be. This dehumanizing, commodifying tendency is inherent in the technologies of enhancement. We will need to be ready to deal with it. Finally, there's the challenge of social fragmentation. Creating a civic culture that can respond constructively to ever-deepening physical and mental diversity among our population. In the end, this will probably require nothing less than a new ethics of personhood, an expanded conception of moral solidarity, a more generous understanding of the word us. I will need to be able to stand before you, acknowledge how radically different you are from me in your looks, your behaviors, and above all, your capabilities, and still feel that underneath it all, we are members of a common family of beings. The public debates over these questions and challenges have already begun. We will all, in the coming years, find it increasingly difficult to stay on the sidelines. The technologies themselves will reach into our lives and compel us to respond. Amid all the perplexities and uncertainties, there is one thing of which we can be reasonably sure: we're in for an exhilarating ride. Thank you.